Well, in this video, we will learn about the term stack, which is a special type of memory that we use during the procedure call. So to use this memory, we have a special register called a stack pointer that store the address of the stack pointer. And we use this stack to, during calling the procedure, once we have a lot of arguments and a lot of local variable. Well, so before study stack, I would like to have a quick look in the procedure call. So as I discussed in the last class, so procedure or function call is a process from the main function call another procedure that you might be used to in many high-level languages. Well, so the caller calls the procedure, okay? The callers call the procedure, and the procedure is the callee. So we can say that the calculate here is the callee. Well, the procedure call, it sends some argument to the callee. And callee receives the argument, and after calculating, callee return the result to the caller, and this is the way the function and procedure call. So 1, 2, 3, 4, 5 steps. Well, let's have an example. So before going to the example, what I would like to say, we have a very particular register in our MIPS register set that is used for the procedure call. The number one is V0 and V1 that is used to the return result. And the register A0 to A3 is the used for the argument. There are four registers that we use to store the argument. And we have a particular register, RA, return address, that store the return address while calling the procedure. So these three types of register are used during the procedure or function call. So the special register are store the value of the program counter plus 4 so that we can again return the position where we call the procedure. Okay, so once you call the procedure, it jump and link with the instruction jump and link, so it automatically saves the current program counter where you are executing plus 4 to the register RA. And once we make the JR, to jump return to the address is take the address from the register RA and start executing that particular instruction. Well, so to be more clear, let's have this example. Here is a very simple MIPS assembly code, and the left line is the memory address, for example. The first line here says that add I S0 012. That means it changed the value of register S1 to 12. Well, and here is the set of register. Among 32 register, I put 1, 2, 3, 4, 5 register. So 2 save register, 2 temporary register, and 1 return address register. That these 5 register are used to execute this MIPS assembly code with the procedure call. Well, once you execute this line, the value of S1 is supposed to be 12, and here is it. Well, in the next line, it calls the jump and link the procedure. So what is happening usually? So once you call the jump and link, it stores the current program counter is now 8, so it stored 12, 8 plus 4 is 12 to the return address here, and go to the procedure address line. Well, so it store the next address 12 to the register and jump to the, for example, if the address is 80, and here start executing this line. It says that S2 register is S1 plus 8. S1 we have 12, and 12 plus 2 8 is 20, so S2 here is supposed to be 20, and here is it. Well, and then it says the jump JR, that means you need to return to the registers. Once this instruction to execute, it first go to the register 31 to find where to go, and the address is 12. So it jump to the 12 and execute this instruction, and it says update the value of S1 with the value of S2 and add S2. So we have S2 is 20, 20 plus 20, it 40. So the S1 is updated to the 40. So this is the way the function call works. So what we see that we have 1, 2, and 3 types of register. So far we used this one register here, and we didn't use this procedure argument register. So now let's find the example to do this. Well, here is another example of high-level code. From the caller, we call a callee, the name is div of function with 4 parameters. It's called arguments. Okay, so the callee receive the 4 argument and return one result to the caller. Well, so let's have a look on the maps code. So this is the part that says the add I a0 is 2, a1, a2, and a3. It consecutively a 2, 4, and 5. That means as our caller having 4 parameters or 4 argument, it stored to the argument register and then move to the jump and link solution. So when it called the jump and link here, so you know already that you use this 4 parameter or this 4 argument, and now you need the internal calculation part. So here is the addition, here is the addition, and then followed by a subtraction to return the result. Okay, so you know the parameter first add, so f plus g, here you just add a1 and a0 and use the temporary register t0 and add it a2 and a3 with the temporary register t1 and the subtraction, this subtraction here is s0. Okay, and you store the result to the return type argument s0 and jump and link over there to execute this. That's it. So here in this example, you use the argument here to store, and then we call the procedure diff of sum, and using this argument you calculate the result and store the return type to the v0 register. It's supposed to be finish of the argument. But what's wrong with that here? Well, think about a tricky situation. In the procedure here, you use the T0, T1, and the S0 register. But you don't know while the main function already used these 3 register or not. So if the main already used this function before calling the diff of sum, and if you use this inside the diff of sum, that means this register value is overwrite, and that make a trouble for the main because you already changed the value of the main function. Here I write this situation, so you have to care about this situation. The diff of sum procedure modifies T0, T1, and S0. If the main had been used T0 and T1 or S0 before the call to the diff of sum procedure, the content of the register would be corrupted by the procedure call. Well, this thing we have to address. And another issue for the procedure call is sometimes the return address could be 64-bit, as all of your register is 32-bit. What we can do, we can use both the V0 and V1 to store the 64-bit result. So when the procedure with then 4 argument, more than 4 argument and we must be used plus to store stack. So in the next video, we will learn about the stack. Until then, enjoy MIPS assembly programming. Thank you.